Welcome to our video on lesson 1.2, segment addition. Objectives: to find the distance between 2 points, to apply the segment addition postulate to solve for x, and to apply the segment addition postulate to find a missing segment. So before we get started, we're just going to do a quick little review, and that's on absolute value. So absolute value is the distance from 0. If I take a walk between 3 points, or from the point 0 to 3, I've gone 3 steps. If I go 3 steps the other way, well, I end up at -3. So from 3 to -3. It's still 3 steps. So whether I go to the right, positive, or I go to the left, negative, I would still describe it as 3 steps. Distance doesn't have any sign associated with it. There's still only 3 steps. So when we talk about distance from 0, we're referring to absolute value. Okay, so we use absolute value to find distance between points. If I want to find the distance from the point 2 to the point 10, well, I would probably take the biggest number and subtract the smallest number, and I get 8. And we can see that there is 8 steps between 2 and 10. Okay, I can do the exact same thing for negative numbers. Now I just took the biggest number and subtracted the smallest number. So let's do this. If I'm at -3 and I go to 5, well, the biggest number is 5. And I'm going to subtract the smallest number. Well, the smallest number is -3. Okay, if I subtract, it's the same thing as adding. If I subtract a negative, and I get 8 spaces. And you can see that there's 1, 2, 3, 4, 5, 6, 7, 8 spaces. So I just took the biggest number and subtracted the smallest number, and I found the distance. We're going to use that idea, the idea of subtracting the biggest from the smallest, and absolute value. Okay, so we're to key issue number 1. How do we find the distance between 2 points on a number line? The distance between any 2 points, x and y, is the absolute value of their difference. Now, it doesn't matter if I do the biggest number minus the smallest number, because we're going to find the absolute value. If you look here, this point x is at 3, and this point y is at 7. If I say 7 minus 3, big minus small, I get 4, and the absolute value of 4 is 4. If I do the small number first and subtract the big number, I get 3 minus 7, and that's -4. But it's the absolute value because I'm looking for distance. The absolute value is 4. So I get the same answer. Now I want you to notice there's 2 smiley faces over here to the side. And what they're doing is they're alerting you to some differences in notation that we're using here. Notice when we refer to distance, we write xy without a line above it. So instead of putting this line that you're used to seeing above every segment, it's just plain xy. Because that xy means the distance between the point x and y. It's not this, where it's referring to the actual figure, xy, the segment xy. This refers to the distance. So no line across the top. The notation for finding the distance between 2 points is just the 2 letters. Okay, so we're going to practice doing this. I want to find the distance between 2 points, between the point K here and L. So I'm going to do the first one. I want to find the distance from K to L. Now I can pick the biggest number and subtract the smallest, or the smallest and subtract the biggest. It doesn't matter. I like not dealing with negative numbers, so I'm going to pick the biggest number, and I'm going to say L is 16. And I'm going to subtract K, which is 12. Okay, so I just found the distance. The absolute value of that distance is 4. I'm going to shut off the video, and you're going to find the distance from J to M. Now what I'd like you to do is, once you found the distance from J to M and you go back to your groups, you want to check your answers and make sure they're right, because those are the answers I'm going to be checking in your notes, and I want to make sure you know how to do them. All right, so let's look at another example, and this time it has negative numbers in here. So I want to find the distance from this point here, A, where it's -5, and this point here, B, -1. So I'm going to do the same thing I did last time, AB. And remember, I want absolute value. The absolute value from, it doesn't matter if I do the big number minus the small. So I'm just going to put down -5. And I'm going to subtract from that a -1. Okay, so negative is a positive. -5 plus 1 is -4, but the absolute value of -4 is 4. So it should be that the distance from here to here is 4. And we can see 1, 2, 3, 4. All right, you're going to take a minute and find the distance from C to A and put your answer in there. Okay, so remember at this point, when you find your answer to CA, you are going to check that answer with one of your partners at your table. All right, so we know we can determine the distance between points on a line. Question number 2. Can we add segments of a line together and get a bigger segment? Well, that makes sense. If I have a small segment and a small segment, I can add them together to get a bigger segment. And we actually have a postulate that says that we can do that. And you need to remember, a postulate does not need to be proven. We just need to accept it as true. So we have a segment addition postulate, and it says, if I have a small segment, A to B, and another segment, B to C, and I add them together, I should get A to C. So 2 small segments add up to a big segment. All right, so let's start with following a few directions, using the correct notation, and just writing some equations. Instructions say to draw the sketch of the 3 collinear points. Then write the segment addition postulate for the points. Now they said there are 3 collinear points, so you need to know that that means that all 3 points are on the same line. The description for number 19 says E is between D and F. So we put down D, we put down F, and we put E in between. And now we write the segment addition. I have DE, a small segment, plus EF, a small segment, and if I add them together, I get the big segment, DF. All right, we're going to do the same thing for this one. This time I need to add some things. I'm missing some points. So I need to have H between G and J. So I'm going to put G and J and stick H in between. Okay, so H is here, G is here, and J is here. Does it matter whether the G is here and the J is here? No, you could switch them. It doesn't matter. But H has to be between. All right, so now I'm just going to write an equation. So I'm going to use my G, H, notice I'm using capital letters, plus HJ, small segment plus small segment, equals the big segment, which is G to J. Okay, so I just followed directions, drew a picture, and then I wrote a rule describing what's going on in that picture. The small segment plus the small segment equals the big segment. And I'd like you to do that to number 21 now. Okay, so remember, when you go back to your group, you're going to check on problem number 21 and make sure yours matches the people in your groups. All right, so we're going to apply that postulate to the job of finding the lengths of missing segments. And the first thing you have to do is notice what we're looking for. So in the first picture right here, we have this segment PQ and another segment QR. And we're looking for what? We're looking for this here where it has a question mark. And what that's saying is it says start the segment here, start the segment there, and go from there to there. Tell me that distance. Okay, so I could write this PQ plus QR equals the length of the whole thing, PR. I know that from PQ is 8, QR is 3, equals PR. This is 11 is equal to P. Oops. Okay, so that's a lot of work to find what looks like a pretty easy problem to do. But you want to know the method that you're using because right now we're using very simple numbers. And we can figure out that if we add this 8 and we add this 3 together, we're going to get 11. So that distance PR is 11. And that's the way you would write your answer. So you would write your answer, PR equals 11. And I'm going to write that down here. PR equals 11. All right, you're going to do the same thing for the next couple. You're going to find the distances from here to here, because we know that's what we're looking for. And down here, the only thing we know is we know this is 15, this is 20, this is 54, and this is the piece that we don't know. So we need to solve for that one. All right, I'm going to do the second one, you're going to do the third one. If I write my equation, I say AB plus BC equals AC. All right, from A to B, I don't know what that is, so we're just going to leave it alone as AB. Plus, BC is 5, and AC is 9. All right, this is just a simple equation where I'm going to move the 5 to the other side, minus 5 from both sides. And I end up with AB, cancel, equals 4. So I just found this like this 4. And you can see that that makes sense. 4 plus 5 is 9. All right, you're going to do the same thing for this last one over here. I'm going to stop the video and let you solve the problem. Okay, so we've only got a few more minutes. We're going to do two different types of problems. This time, we don't know the lengths of the segments, but we do know how the segments are related. And then you have to ask yourself, what am I looking for? So notice in this problem right here, it says right at the beginning of the problem, solve for x. So I want to know what x is. I can do the same thing I did a few minutes ago, where I can just write an equation. So let's do that. I have a big segment here, well, relatively big. I have CD, plus I have DE, and that equals CE. So I have the small segment plus small segment equals the full length. CD is x plus 7. And DE is x plus 2, so we can add that together. Equals CE is 7. Okay, so now I have an equation. I'm going to add like terms. I have an x here and an x here. And if I add them together, I have two x's. I have a 7 here and a 2 there, and if I add them together, I get 9. Okay, now I'm going to continue solving. I'm going to move that 9 to the other side. I have 2x equals negative 2. I'm going to divide both sides by 2. And I get x is equal to negative 1. Now, I always want to check my answer to see if that makes sense, if x is negative 1. So let's come back up here, and I'll pull that back down so you can see it in a minute. But if x is negative 1 plus 7 is 6. And negative 1 plus 2 is 1. So if I add 6 plus 1, do I get the length of 7? I do. Okay, I'm going to pull this down so you can see what I did. Here's my work. And you're going to do the problem next to it. So let's pull that down so you can see it. Okay, take a minute and solve that. All right, so we're on to our last problem. This time we're looking for KJ. I want to know the distance from there to there. All right, I know that from L to K is x plus 7. And I know that from K to J is x plus 5. And I know the whole thing is equal to 12. All right, I'm going to combine like terms. I have two x's here, so I have two x's. And if I add 7 plus 5, I get 12. All right, I'm going to move that 12 to the other side. So now I have 2x is equal to 0. Ooh, I just found out that x is 0. I'm going to come back up here and plug this in. And I just found that kj is 5. Okay, I would like you to do the same thing for the next one and solve for db. Any questions? Please hold them until you come into class the next day, and I will be happy to go over all of the problems with you that you worked on today. See you tomorrow.